And welcome back to another LeetCode video where we use a LeetCode problem to practice the interview process. And the reason why I'm doing this is because it's good practice. So my approach is a little bit more thorough, where I really try to simulate an interview by going through the problem in a systematic way. Obviously, I don't have somebody who interviews me, but I'll pretend I do. It's a little bit like a mock interview light, I suppose. However, I don't get any hints really. So what I do is, step 1, understand the problem. Step 2, check out the constraints or ask for the constraints. Step 3, work through some examples to maybe get an idea of how to solve the problem and possible edge cases. Then come up with one or multiple approaches how to solve the problem, including runtime and space complexity, before writing a single line of code. That's really key. If you can do that, that demonstrates that you have some level of mastery, and you're avoiding the great danger of poking around in code and not knowing what you're trying to fix or why is it failing. You always want to be clear of what your solution is going to look like before you start coding. That's like the golden rule for interviews, at least. And then finally, we will use the examples we've seen before to step through the code with a mental debugger to make sure that we didn't miss anything. Or if we have logic errors, we want to uncover them before we submit our code for tests. Cool. So let's dive into that. This is LeetCode 2294, partition array such that maximum difference is k. And it's a medium problem. So you're given an integer array nums and an integer k. You may partition nums into one or more subsequences such that each element nums appears in exactly one of the subsequences. Right, return the minimum number of subsequences needed such that the difference between the maximum and the minimum values in each subsequence is at most k. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. Interesting. Okay, so I guess my first question would be, well, nums, is that how many elements are always going to be in there? Can nums be none? Can it be empty? What's the value range? And what is the value range of k? Is it guaranteed that there's a solution? That type of stuff. But since I can't ask anyone, I'm just going to look at the constraints here. Right, and it tells us the length of the nums array is at least 1. And the values range between 0 and some positive large number. And same for k. K can be 0. Interesting. So k is the maximum allowed difference, right? All right, so let's have a look at an example, because right now I'm not quite sure, can I just pick any numbers in random order? How does that work? Or can I just compile my own numbers? All right, we can put, because it says this, subsequence, explain what a subsequence is, but that's not clear of whether the numbers in our partition array also need to remain in their order or not. Right, so example 1. So we have a nums array 3, 6, 1, 5, and k is 2. So the maximum difference between elements and subarrays is going to be 2. And we can partition nums into 2 subsequences. The subsequence 3, 1, 2 and 6, 5. Okay. But why would the order matter? By the way, what are we giving back? What should we return? Oh, the number of subsequence. Yeah, so I'm suspecting the order doesn't even matter. Because if this is 1, 2, 3 or 6, 5, who cares? I can pick elements for my subsequence from anywhere in the array, right? I just can't pick a number twice. So yeah, so we can completely forget the thing about the ordering, I think. The difference between the maximum and the minimum value is, well, 2 in the first subsequence and 1 in the second. So both are smaller or equal than k. Nice. Example number 2. We have 1, 2, 3 and k is 1. We can partition nums into 2 subsequences, 1 and 2. Then the maximum difference is 1, which is allowed. And then the remaining subsequence only has 1 element, which has a maximum difference of 3, right? So that's also allowed. Here we have nums oh, we can have duplicate numbers and nums apparently. And here the maximum difference is 0, so we can group together the two 2's. And 4 and 5 need to be in their own subsequence. So the result is 3. Okay, interesting. All right. Well, so, okay. So what I think is, I think we should sort this thing. Then we just iterate over it and combine as many numbers until the difference between the minimum and the new number is larger than k. That means we need to make a cut and need to start a new subsequence. You know what I mean? So if we do, we have this array here. We sorted that 1, 2, 3, 5, 6. Now, and we have, you know, what do we have? K is equal to 2. What we'll do is, well, we have 1. That's our minimum. 2. So what is the difference now? It's 1. 3. So the difference is now 2. If we add 5, we go over that difference. So we make a split here, and then we start a new subsequence. And then we start with 5. That's our new minimum of our current subsequence. 6. The difference is 1. That's fine. And then we've reached the end. So that's why we get to the result of 2. And I'm interested in this case down here as well. So where we have duplicates. So here what we would do is we would take 2. Well, this is already in sorted order, so we don't have to sort it here, right? So we take 2 and 2. And that can be one sequence, but as soon as we run into, and 2 is the minimum, but as soon as we run into the number where the difference to our previous minimum is larger than 0, we have to start a new subsequence. And that's why we can't add the 5 into the subsequence with 4. So now we have the result of 3. Yeah, I think that's what we're going to do. So that's a little bit like a greedy approach, right? Where we try to increase the size of our subsequence for as long as we can. And if we can't do any further, we'll just make a choppity chop, and start a new subsequence from that position. Right, so I think we have an O of n log n time and O of 1 base solution. Let me just think about maybe a different approach that we could take. You know, I was thinking that, you know, since the number values are so large, yeah, yeah, since they're so large and they are not guaranteed that they all are, let's say if it's, for example, guaranteed that all values are between, I don't know, 1 and 10, and then it would be kind of easy to pick numbers maybe from a hash map or something, you know, where we pick a number from the hash map and then try to find numbers that are smaller. But yeah, so I think that's that. I don't know, maybe if a union find approach would work. I don't know. But I think this one is the most direct, practical way that I would try. Like a brute force approach would obviously be find the minimum, try to find the next smaller number, and so on, where you don't sort. But that sounds really stupid. Excuse my English, but yeah. So I think that is the solution that I would like to implement. The interviewer, are you okay with that? And then the interviewer says, yeah, of course, it sounds awesome. Right. So now I'm going to put that into code. So I'm going to do exactly what I just did when walking through the examples, right? So I'm translating that one-to-one into code. And that is why it's so important to actually go through the examples, you know? Right, so yeah, so nums.sort, we're going to sort that. And now we need to keep track of the current minimum. How should we call it? Sequence, current sequence minimum. And we need to initialize that with something. I don't think we'll do something wrong when we just use the current one. And then we just iterate over all of the numbers. We don't even care about the indices because we know they are in non-decreasing order. And now we check, well, can we add the current number to our sequence or no? Right, so if n minus current sequence minimum, because we know n is going to be larger or equal, so this is always going to be a positive value. 0 counts as a positive value. If that is larger than k, that means we cannot add n to our current sequence. Right? It can't be part of the current sequence. So what we do is we have to do our little result plus 1. And we have to remember what the new minimum is. And the new minimum is the next number n. Right? The new sequence starts with the number n. So that's new minimum. Right. Cool. And then we just continue. Now, with these, it's kind of like a sliding window approach, but we don't really need to keep track of the entire window. We just need to keep track of the minimum. But the minimum is always at the beginning of the window since the numbers are sorted. I don't know if you can see that, but that's basically what this is. Now, with these approaches, you always need to also process the last window that wasn't closed, right? So what can happen is just like in this example here, we had the 5, we had the 6, and the difference is still 1, not 2, right? Or not larger than 2. And then we terminated. So we had elements in our window, but we did not count this subsequence here. So the way to fix it is to initialize our result with 1. And so it's always guaranteed that we have one subsequence anyways, because we know that we always have an element, our nums, and we know that k is 0 or more. And when it's 0, that means you have as many subsequences as you have distinct numbers. So at least 1. Right, so I think that fixes this off by 1 problem. You could also, at the very end, to account for the current open window, just add result plus 1. But yeah, we can also put that up here, whichever you prefer. But you need to be able to explain why you're doing it, right? Why are you adding the plus 1? Or to fix the off by 1 error. Cool. So even though this sounds repetitive, let's just go through an example. I will just go through this one. So nums, our minimum is going to be the first number, which is going to be 2. It's going to be 2. Now nums is going to be 2 as well. So this is definitely not larger than k. What is our k? Our k is 0. It's not larger than 0. Cool. So it's 2. Next number is also 2. So nothing happens. Next number then is 4. Now we run into this thing where we set the minimum. We set the current minimum from 2 gets set to 4, and we increase our result by plus 1. So from 0 it goes to 1. Next we run into 5, same thing. The current new minimum goes 1, and we increase our result to 2. And well, then we're already done, and we increase our result to 3 in the last row, which is exactly what we expect. Yeah, so I'm confident that this will work. Let me just remove these comments here. Right. By the way, there's no rule on how to explain when you walk through the code. You know, if you have a drawing board, that could help as well. Annotating maybe the values also helps. It's really just used as a communication tool, so your interviewer knows what you're talking about. Otherwise, you know, if you just throw around a bunch of numbers and say here and there and this and that, they might not necessarily know what specifically you currently have in your mind. So let's run the tests. Cool. So all of these test cases pass. And let me just remove that. And I'm now going to submit the solution to make sure that all of the test cases pass. And there you go. That's your solution.